We're going to start talking about domain and range. Again, just as a reminder, look how they even wrote domain and range. Why did they write, other than trying to look cute or whatever, why did they write it this way? X and Y axis. See, like right here, the domain is the X. That's the horizontal axis. It goes from left to right. The range is vertical. It's the Y. It goes up and down. Okay, you need to make sure you remember that. Now, what do these symbols mean? Let's start off with this one right here. The arrow is pointing to the left. That symbol means less than. You read it from left to right. The little point is to the left. That's less than. On the next one, reading it from left to right, the bigger side is on the left. That's greater than. These are what's on the back of your paper. Now, what does it mean when there's a bar underneath of it? Equal to. So this first one on the left is less than or equal to. This other symbol right here, that's greater than or equal to. Now we're going to talk about what we remember. Oh my goodness, can I stutter some more? What we remember about domain and range. So, what does this mean right here? What does domain 3 less than x less than 8 mean? Three is less than x, and x is less than 8, yeah. Cassandra? Okay. Yeah, because if I graphed it on a number line, if I graphed it on a horizontal axis, and I went over here from 3 to 8, my x numbers are in between all these numbers from 3 and 8. Does it equal 3 and 8? No, because it doesn't say equal to. And you will talk more about this later, but when it's an open circle, it's not equal to. And then to show all the points in between 3 and 8, we just shade in between those points. Yes, ma'am. Yes. Yes, 3 and 8 exclusive. Between 3 and 8 exclusive. Range, when you're talking about the range, you're talking about the vertical, going up and down. Okay, and it doesn't have an equal to bar. It's starting at -2, and it goes up to 7. And when it's not equal to, again, you just put open circles, and you shade in between. Now, somebody get the door. This is one of the ways that they write it. Like they'll put, this is just a fancy way of writing it. Domain equals, and they use set notation. They put the X in there for domain, and then put their numbers. Okay, range, same thing with their Y, is right here when they use the Y in this little line. I mean, it's not that big a deal on right now on what we're doing, but it's just so if you see it. I'm waiting a second because some of you guys are writing it down. This time when I see something and it says domain, x is less than or equal to 5, and range is less than 4. They're just showing you another way of writing it here. But like, for example, on the domain being less than or equal to 5. At 5, I would have a closed circle at 5. If it was less than, I would shade to the left. my range, oh, I can't draw it vertically. I have to draw it horizontally. I said that backwards. On the range, you have to draw it so that it goes up and down so that it is vertical. And so where I have 4, first off, does it say equal to 4? No, so I'm going to have an open circle. And it says less than 4. Which way do I graph if it's less than 4? Above or below? Below. Okay, some of this will tie in just a little bit. All right, so now that we're looking at this, here is a graph. You still don't have it on your paper yet. You don't have it on your graph, but it wants me to highlight the domain in the yellow. So first off, you just need to remember, I cannot figure out where my highlighter is anymore on my little doohickeys here. Well, golly gee. I spend too much time trying to find it. Oh, there's a highlighter. What's happening? There we go. Highlight the domain in the yellow. These numbers right here they're going to be my domain. And it wants me to highlight my range in the green. My range is what whoa, nice. I'm doing this with my right hand. I'm left-handed. There we go. All right. Range is what's going on up and down. Now, in this, is my data discrete or continuous? Discrete because it has the dots. When I do domain and range of this, I would have to have the exact points. Like this point up here is, each line's going by 25. This is 0 and 525. The next point is 1 and 450. 2 and 375. 3 and 300. 4 and, what is that, 225? 5 and 150. 6 and 75. And 7 and 0. So again, on this, if I'm looking at these numbers, my domain is all the X numbers. So it would be my domain, if I wrote it, domain with my set notation, my X numbers, 0, 1, 2, 3, whoops, it changed colors, 4, 5, 6, 7. And I'm writing specific numbers because they are dots. Now my range is all this over here in green. My range would be, I guess I didn't need to come down this far. Let's see. 525, 450, 375, 300, 225, 150, 75, and 0. Okay, that's giving me my domain is all my X numbers, my range is all my Y numbers. Oh, guess I already did all that. They asked those questions. So that's my domain. If I go down here, I'll bring all my green ones. There we go, piece it all together. My domain and range, which we've done before. Okay, so now flip your papers over. This is to the part that you have written down on your paper, or the copied part. It says an airplane is 2,500 miles from the city of Houston. The airplane is flying 150 miles per hour towards Houston. If X represents the number of hours and Y represents the distance from Houston, write an equation to represent the total distance of the airplane from Houston. This is where we struggle. First off, what is my starting point? Where are we starting to find our information at? When the plane is where? 2,500 feet. This is my starting point. Circle that on your paper. Starting point. And it's flying towards us at a rate of 150 miles per hour. This is my rate of change. So to find my equation, y equals, you start at your starting point. Now, am I going to add or subtract the 150? If I add it, the plane's going to go away from us. They're trying to figure out how soon the plane is going to get to Houston. It's 2,500 miles away. How soon is the plane going to get here if it's flying 150 miles per hour? So you're going to subtract off 150 miles per hour. Now, is this data going to be continuous or discrete? Discrete would mean that you fly only in certain, like you go from 2,500 miles to 2,000 miles automatically, like poof. Continuous because you go through every point. You start at 2,500 miles away, and then you keep getting closer and closer and closer. Because of that, this is going to be continuous. Now it asks you, what is the domain of the situation? Well, domain, what we need to do now is go into your calculators. Let's go into y equals. Put in there 2,500 minus 150x. And let's go second graph. Let's look at our table. We are starting out 2,500 miles away. When do we get to Houston? Where do I look? How do I know when we get to Houston? Like, I'm just going to scroll down in the calculator, but what am I looking for? Somebody said 16 hours. 16 hours, they're still 100 miles away. It's going to be in between 16 and 17 because all of a sudden you go from 100 miles away to negative 50. On a graph, let me ask you this. On a graph, when the line's going like this point up here, the y-intercept, the constant up here, this is your 2,500. That's your starting point. It's where it crosses the y-axis. Down here, this is some number and 0. This x-intercept, where it crosses your x-axis, this is when the plane gets to Houston. So when they ask you what does the x-intercept mean, it means this is where the plane gets to Houston. So now when it says state the domain, we know it's continuous, so I've got to have where my numbers are between things. So first off, it starts out, let's look at my calculator again. I start at the time of 0, and when I get to Houston, it's somewhere between 16 and 17. For this, we'll go ahead and write 17, or 6, I guess we could put 16.5. To find out when it crosses. So let me see. Let me go second. I'll show you a little trick here if I can get my calculator here. Second window. I'm going to type in there 16.5. I'm guessing. Second graph. At 16 and a half hours, I'm still 25 miles away. See how it has a positive 25? All right, so let me go back a second. I thought maybe it would cross nicely. So let me go to 16. So for my domain, we're going to write this as we start at 0. X is in between 0 and I'll go with 17 right now, even though it's not real friendly. The X is in the middle. Now, whenever you have this, you take the smaller number that's over here on the left and the larger on the right. Your symbols are always going to point with the less than symbol. Now, it needs to be equal to, because we're starting at 2,500 and we're landing, we're crossing at 17 or 16 or 17 down there. Now, my range, when it's talking about my range, it's talking about my height. My height, I'm starting at 2,500, and when am I ending? When my Y number is what? It's 0, when my Y number is 0. So my range is from 0 to 2,500. And I'm going to put the Y in between there. And then I'm going to put the less than or equal to symbols so that it says 0 less than or equal to Y less than or equal to 2,500. My graph, let me erase my ghetto graph. Here's my graph. So again, right here, up here at 2,500, this is my y-intercept where it crosses the y-axis. That's my starting point. Where it crosses my x-axis, my x-intercept, that's when the plane lands. Which one is, oops. What does that ask me? So again, if I went to go highlight and look at my domain and range, my domain is down here. It's these numbers from 0 out to about 16 point something. My range is from 0 up to 2,500. Okay, let's look at the next one. Oh, well, what are we doing here? I already did all that. All right. Here are two graphs. There is a graph of the equation, meaning if I just put the equation in the calculator, it gives me this line. You see how it goes? The line goes past the first quadrant, and it goes down here past the first quadrant. That's because this line, when you just put an equation in the calculator, it goes on forever and ever and ever. Okay, and there's no stopping. The situation, we are applying a word problem to this graph. And if you notice in the situation, it stops at those certain points. It stops at 2,500. It stops at 16 point something. That's because we can't go down here. We can't go below. Where'd my thing go? There we go. We can't go down here when you're talking about a plane and trying to come closer to Houston. You can't be negative 10 feet away from Houston. Okay? Your numbers always have to be positive. Now, if they were asking you about domain and range, this is very important. Look at the difference here. When they talk about domain and range of a situation, they're talking about specific numbers. If they're talking about domain and range of an equation, your equation is always going to say all real numbers, because in the calculator, it doesn't know that we're making it apply to a certain problem. It is just every number that could show up. So anytime, hint, 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 on your paper, anytime it asks you what is the domain or range of an equation, it is always all real numbers. Hint, hint, hint. Write it down. Write it down. If it is of a situation, it means that it is certain numbers. That is the same about the range. When you are talking about, anytime you're talking about just the equation, the domain and range is always all real numbers, because it can be any number in the calculator. Situations are when we apply things to an equation, making it specific values or points. Situation. Okay, now, right here, looking at the next one, it says each person went through the drive-through, brought some numbers of tacos and drink. Below are the receipts of their purchases. First, it wants us to write an equation for the table. Now, when I go to write my equation, I like to turn mine so that it is vertical, not horizontal. So I have X and I have Y. So I'm going to have 2, 3, 5, 8, and 12. Then I have 5, 6.25, 8.75, 12.50, 17.5. Okay, to find the equation, step 1, you need to do delta Y. You need to do the change in Y. So my change in Y, at first, how do you get from 5 to 625? You add $1.25. The next one, how do you get from 625 to 875? You add $2.50. You 625 plus 225 is 875. The next one, to get from 875 to 1250, you can take 1250 minus 875 in the calculator, and it will tell you. It's something 75, 375. The next one, how do you get from 1250 to 1750? Add 5. Now, all of these are different, but that doesn't mean anything right now. You have to find delta X, the change in X. Right here, it's plus 1. How do you get from 2 to 5? Sorry, 3 to 5 plus 2. From 5 to 8 plus 3. From 8 to 12 plus 4. Now, you need to make sure that we have a consistent rate of change because we have to figure out if it's linear first. You take delta Y divided by delta X. 1.25 divided by 1 is $1.25. The next one, 250 divided by 2, $1.25. 375 divided by 3, $1.25. Okay, those rate of change is $1.25. The rate of change goes right here. 125 goes first in your table. What you are supposed to do next is multiply your rate of change times your X. Okay, once you do that, you need to figure out what you have to add or subtract to get your constant so that you equal your Y number. So what I mean, take and multiply. What is $1.25 times 2? If you take 125 times 2, you get $2.50 for that first one. What do you have to do to 250 to get to 5? If you have $2.50, what do you have to do to it, add to it to get to $5? Well, we got to add or subtract, not multiply. Okay, so you're going to have to add $2.50. One of the ways you can do that to find your constant is to take 5 minus that 250 and it will give it to you. The constant should be the same the whole way down. Now, with your equation should now be Y equals 125x plus $2.50. This is your equation. To check it, you put your equation into Y1, you press second graph, and you go and make sure that these points are in your table. I'm going to stop for a second, and I'm going to tell you right now, if you are not able to do that table building, I'm going to go back in a minute. you need to go into YouTube and in the search bar type in Craw Mama 1. Make sure you use 2 M's and the number 1. Craw Mama 1, and you need to type in table building. You've got to learn how to do that, and if you don't know, you need to spend time to do that before your test. Okay, back here. Now, my domain, it says to highlight my domain in yellow. What information is my domain? It should be the number of tacos, which is my X. So when it wants you to state your domain, you put it in set notation, and I'll label 2, 3, 5, 8, and 12. It is those specific numbers. Your range, they want me to highlight my range in green. My range is my Y numbers. So when I go to write my range, I should write R equals set notation, $5, $6.25, $8.75, $12.50, and $17.50. Why do we write it like this instead of with the less than or equal to symbols? This data is what? Well, it is linear. Delta y over delta x is the same, but so was the other one. Not circles are open. The things I'm talking about, is this data discrete or continuous? It should be discrete, because can you go to Taco Bell and say I want half of a taco? No, you can't. You're either going to buy 1 taco, 2 tacos, 3 tacos. Your graph, well, I need more room here. Nope, not that one. Try again. Your graph, hello, it's just going to be dots, because you're only buying certain numbers of tacos. All right. So now let's look at the difference between these two graphs. Okay? Looking at the situation and the equation. When you're talking about domain and range of a situation versus just an equation. Remember, this one over here, this line is just the equation. This is if I just put the equation in the calculator and press graph, this is what it'll show me. It gives you a line. So anytime they ask you what is the domain and range of an equation, highlight, highlight, highlight that, it is always all real numbers. When you are talking about a situation and you are applying a certain problem to it, that's when it becomes certain numbers. That's why it's just 2, 3, 5, 8, and 12. Okay, let's look at this one. On your next one, it says, if a bathtub holds 80 gallons of water, a bathtub fills at a rate of 1.8 gallons per minute. Write the domain and range. Well, it says that the bathtub holds 80 gallons at most. Write the domain. So first off, we need to write an equation. Take a second right now and write your equation. All right, so it says that the bathtub fills at a rate of 1.8 gallons per minute. First off, what are the two things we're talking about? What are my X and the Y? It is, it's going to be the number of gallons. Oh, wrong thing. I put it in the X. The gallons should go in the Y. So we're going to have minutes. And we're going to have gallons. Okay? So right here, first off, I've got Y equals, my rate of change is $1, 1.8, and I'm going to take it times my number of minutes. Now it says to write the domain of the situation. First thing we want to talk about is this continuous or is it discrete? It should be continuous because you have to go, if the bathtub holds up to 80 gallons, when I fill it up, it gradually keeps adding more and more water. So it's got to go through every decimal. But so now I need to see how long does it take to get up to 80 gallons, right? So I need to look in the calculator and find out when y is 80. Or you could do this by hand and you have 1.8x equals 80. Take 80 and divide it by 1.8. What do you get? X equals 4.4. X is the number of minutes. Can you have 4.4 minutes? Yes, you can. You can have 4.4 minutes. That's in between 4 and 5. So now when it asks you to write the domain, I know that we start at time 0. So my domain equals set notation 0. Oh, not 0. I got to put that X, that other stuff. I've got X. So now I start at 0. And when does my bathtub fill all the way up? At what time? 4.4. X is in between it. So I put the small number to the left, large number to the right. Less than or equal to, less than or equal to. That is my domain. Now my range. What would my range be? The bathtub is empty, so it starts at what? 0, and it goes up to what? 80. X is in between it. Y is in between it. I'm as tired as some of you guys. And I have less than or equal to, less than or equal to. That's my range. Okay, because it holds from 0 to 80 gallons. And it takes 0 to 4.4 seconds in order to fill it up. Okay, let's look at the next one. It says Sandra goes to the bakery to buy donuts. Each donut she buys costs 50 cents. Write an equation to model the situation, or write an equation to model the situation. Okay, so right now I want you to write your equation based on that information right there. Okay, so to write the equation, first off, what are the two things we're talking about? Donuts and money. So on my table here that I'm drawing, my X is going to be my number of donuts. My Y is going to be my cost. Well, Y equals, I'm paying 50 cents times X because X is each donut. Yes, Y equals 0.50 times X. So it says, what is the domain of this situation? First off, is this data going to be continuous or discrete? Discrete. So I'm going to either have 0 donuts, 1, 2, 3. And then my cost, if you buy 0 donuts, you don't pay anything. 1 donut is 50 cents. 2 donuts cost you $1. 3 donuts cost you $1.50. Okay, so when we're talking about the domain of the situation means the donut problem right now. So I'm going to have my domain equals, I've got this set notation, X and a line, and I'm going to put 0, 1, 2, 3, and then I'm going to put ... and close my set notation because it doesn't give us a specific amount that the donuts stop at. Then it says, state the range of the situation. The range, I put R equals my set notation, Y in a line, and I'm going to start at 0, 50 cents, a dollar, $1.50, dot, 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 because it could go on up. This is of the situation. It's of talking about how many donuts. Now, if it asked you, because we wrote an equation, y equals 0.50x, state the domain of the equation. If it is an equation, if I put y equals 0.50x in the calculator, will it give me only certain numbers, or will it give me a line? It'll give me a line. The domain of the equation is all real numbers. You just write the words all real numbers. And for range of the equation, all real numbers. That's all you write for that. Anytime it asks you of just the equation. Okay, so now on the next problem it says John had $20 to buy cupcakes. Just Desserts charges $1 for the box and $3.50 for each cupcake. Write an equation to model the situation and state the domain. Okay, so when you look at this first, we need to, you may have to, if on the paper you have, you may want to look at, you may want to write this on the back. When I look, what I'm talking about, I've got X is going to be the number of cupcakes that I buy, and Y is going to be my cost. So 0 cupcakes. If I buy nothing, I could just go in there and buy the box, and the box is $1. 1 cupcake, I still have to pay for the box, and then it's $3.50 for that cupcake. So that would be $4.50. 2 cupcakes, that means I've got to go up by $3.50 again. So what is that? $8. 3 cupcakes, I go increase again by $3.50, so that's $11.50. 4 cupcakes, again up by $3.50. $12.15. And 5 is $18.50. Now that should help us be able to write our equation. You can build a table now with this information, and you can do the change in y over the change in x with your table building to find out your equation. Or you can go through and see this. I know that I am paying one time the $1 for the box. This is a one-time charge, so this is my constant. $3.50 for each cupcake. That is my rate of change. So my equation becomes y equals my rate of change times the x plus or minus my constant. So now I have y equals 350x plus 1. Okay, so there's my equation. Now, they gave me my table over here. So here's my table. If I wanted to do it this way. Now, once you built your table and you wanted to make sure you did it right, put this equation into y equals, press second graph, and make sure that that's my table. It asked us to state the domain for this situation. Well, first off, in this situation, is this continuous or discrete? It needs to be discrete because you're talking about buying cupcakes. You can't go in there and buy a half of a cupcake. So my equation, well, there's my equation. And then it's got to be discrete. So my domain, oh my goodness gracious. My domain is going to be 0, 1, 2. Now wait a minute. It said I only had how much money? I only have $20. So looking at my table right here, what's the most amount of cupcakes I can buy? At 6, it's going to cost me $22. I don't have enough for that. At 5, it cost me $18.50, so that means I have some change. So my domain would only go up to 5. Oh, why did I go from 3 to 5? To 3, 4, and 5. So you would write your domain only up to 5 because we don't have enough money for 6 cupcakes. What two things do you need to be careful of to look? Wait, I keep reading this wrong. What two things do you need to be careful to look for when you're determining domain and range? What do you think? One of the things I kept asking you was, on there I kept asking, is this data discrete or is it continuous? So that's one of the things you need to make sure and see. Is it discrete or continuous? That'll make a difference of how you write your domain and range. Go 10. Oh, I think I spelled it wrong. Here we go. Continuous. The other thing is you need to look and see, are they asking you about a certain situation or are they asking you about an equation? And remember, in that equation, whenever I ask you for domain and range of the equation, it's always all real numbers.